All right, let's take a look at this. We're going to do standard, we're looking at normal distributions, given a certain amount of information, how do you find the mean or standard deviation, okay? So first things first is we know we're working with a normal distribution, and the mean is going to be right here in the middle if the distribution is normal. And that location has a z-score of 0, right? Because the mean is 0 standard deviations away from itself. And let's see here. Okay, so what other information do we have? Okay, so let's say that we're looking at IQ scores, and let's say that the problem tells us that some percentage or proportion. Okay, so we're looking at like 58% of the people that took a certain IQ test or whatever. Let's say that they have an IQ that's greater than 100. Okay. They have an IQ that's greater than 100. All right, so that's what we know. Oh, and then we need to know one other piece of information. So let's say that we know that the standard deviation is 16, okay? And so that means we're going to be finding the mean, okay? We want to know what value is sitting right here, okay? If they had told us the mean instead of the standard deviation, then we'd be finding the standard deviation, right? So they have to give us one piece of information so that we can find the other, all right? So now, but the one thing that's always going to be the same is this first part, right? They're always going to tell us a certain percentage of the population. And a really important thing I think to do in problems like this is you need to visualize what's going on, okay? So for me, when I'm working on something like this, I try to plot this. I plot it right onto the normal distribution, okay? We know that the mean marks the halfway point, right? So 50% of the distribution is lower than it, 50% of the distribution is higher than it, okay? So this here is telling us that 58% of people have an IQ that's greater than 100, okay? So that greater sign tells us where we want to be. We want to be on this side of the distribution because it's going to be a greater, right? I would shade, if I only shade in this much, then I have just 50% is greater, okay? But I know it's 58. So I know I'm going to be on this side of the mean a little bit so that I can get that extra 8%, right? So now I've got 58% of the distribution selected, okay? So if I bar this off, right, this is 58% of the distribution is greater. And then that also tells us that over here, right, 42% of the distribution is lower, all right? So now where do we go from here, right? We've got this marked onto the curve. What do we do? What I really want to know is what is the z-score at that breaking point, okay? What does z equal right there, okay? We know that it has to be a negative value, right? Because we're to the left of the mean, right? That's a 0 of 0, so any of these z's are going to be negative. Any of these z's are going to be positive, okay? So, I mean, so that little bit of information is going to help us as we move forward. Now, you can use a table to look up this proportion and to figure out what's going on. Or Alex has a really cool calculator tool that you can just use. Inside that calculator tool, there's a button that looks like this. It's a Z with a little box. And essentially what we're trying to do is we're trying to figure out, okay, what goes into, we want to know what Z-score gives us a proportion of 58%, okay? So into the little box, you're not going to put 58, right? Because we want to know the proportion, so that's 0.58. So, right, you're going to do z of 0.58, the proportion, what z-square is that? When you run that into a calculator, and you can find calculators like this online, there's tons of them for free. In fact, you could probably just Google it and it would tell you. Anyways, the little z calculator is going to tell us that that matches a z-score of 0.201893, and it's negative. And that's good, right? We knew that it had to be a negative, so our answer had better come out negative, right? So that gives me some confidence in that number that I'm seeing, okay? If you had put in 42, by the way, instead of 58, then it would have given you a positive value here instead of a negative value, because it would have thought you were looking for this thing, for that proportion. But we're not. We want the negative sign, okay? And so we know we're on the right track because we got a negative z-score. Okay, and that's what we were expecting. So again, my z-score is negative 0.201893. And I want to carry as many decimal places as I can right now, just because you don't ever want to round until you get to your final answer. Otherwise, you introduce what's called rounding error into your calculation, and that's no good. So z equals this. Well, z also equals some value in my distribution minus the average divided by the standard deviation. Okay, and look, here's the thing that I want. I want to find out what the average is, and there it is in this equation that I'm looking at. So I can fill this side out. I know that x, we're looking at the proportion is this z-score, right, matches 100, right? That's where this came from. So it's the value of 100 minus whatever the average is, divided by the standard deviation, which is 16, equals this thing, negative 0.201893. And now I just need to do some algebra to get the mean by itself, right? You're going to multiply each side by 16. Then you're going to subtract 100 from each side. And then the last thing is you have to get rid of that negative, so you'll take each side and multiply it by -1. When you go through all of that, you end up finding that the average is 103.2. And this I've rounded because that's my final answer. And then we can check, right? We can check and see, does this make sense? Well, okay, here's my distribution. Here's the thing that I'm measuring. Here's the mean, okay? I know that this thing has a value of 100. It has a z-score of negative 0.201. This thing has a z-score of 0. And so it should be just a little bit bigger, right? The z-score is a little bit bigger. This should be just a little bit bigger, and it is 103.2. Boom. So I know I'm on the right track, right? Everything is pointing and telling me that I've got the right answer here, because I can see I went from 100 to just a little bit bigger. I have this z-score that's a little bit smaller as it gets closer to the mean. So this gives me a lot of confidence that I'm on the right track and that I have the right answer. If we'd been looking for the standard deviation, it's just everything would have been the same up to this point. It's just that instead of solving for the mean, I'd be solving for the standard deviation. So the algebra would be a teeny bit different, but it essentially would have been the same process. But this is what's going on. Let me know if you have any other questions about this, and good luck. Thanks. Bye.